Now that we know the main adhesive families, it's time to select the adhesive for a particular application. For example, the automotive industry.
So now we know the main adhesive families, structural, non-structural. It's time to select the adhesive. How do we select the adhesive? Where we have to take into account various factors: the substrate, the production requirements, design and loading, and service environment. With these four, we select the adhesive, and then we need to characterize the mechanical properties of the adhesive. Let's start with the substrate. How do we select the adhesive for a particular substrate? Well, we need to take into account the principle of minimum energy. That's what we have seen in the theory of adhesion. We need to make sure that the surface energy of the adhesive is lower than that of the substrate. In general, we don't really verify that, in the sense that we don't measure the surface energy of the adhesive and the substrate. We go to tables that will tell us for a particular substrate what is the adhesive most adequate. But behind that table is this, the principle of minimum energy and the question of the surface energies of the adhesive and the substrate. Concerning the production requirements, there are many points that we should take into account: adhesive form, method of application, working time or pot life. That's an important one. After you mix the adhesive, you have a certain time to apply the adhesive before it hardens. Some of them we are talking about seconds, for example, cyanoacrylate, the superglue. Others you have hours, so you have plenty of time to apply the adhesive. But in case you have big surface to bond, you cannot, of course, use an acrylic adhesive that will harden very, very quickly. Curing conditions, temperature, pressure, time. Some substrates you cannot use a high pressure. Holding time, I have already discussed this. It's the time after you apply the adhesive and join the substrates you have before you can handle the substrate. It's not fully cured, but you can already handle. You can move it to another part of the production, or you can use the structure. In the case of the one part polyurethane that is used in the windscreen, you can drive your car 1 hour after it's applied, but in fact it takes 2 weeks to fully harden, so the handling time in that case is about 1 hour. So many constraints, many limits that can, as I said, limit the selection of the adhesive. Another good example, for example, you have many applications where you need really a thick bond line. For example, in the wind blades, the thickness can vary from 1 millimeter to 10 millimeters in other places. Of course, you cannot use a film adhesive that has a very limited thickness. In that case, you need a paste adhesives that can fill the gaps from 1 to 10 millimeters. So these production requirements is really something that you need to be very, very, very careful. Then design and loading. I remind you that you have many loading conditions, and you always try to have shear, but in many situations you have a peel, and if you know that peel will be the main loading mode, then it's better to use an adhesive that can spread the load over a bigger area. Typically we prefer in that case a flexible adhesive like a polyurethane or a silicone, something like that. For the service environment, you have one very important point to verify, which is the glass transition temperature. If you are talking about a structural application, an adhesive is only structural if it's used below the TG, below the glass transition temperature. Again, you don't check for all adhesives the TG. What you do is you go to the table or you go to the data sheet of the adhesive and you check what is the TG, and you make sure that the adhesive will be used below the TG. You have in this table an indication for the main adhesive families that we have discussed in previous modules, and that can help you to select the proper adhesive. I have also here this chart that helps to select the adhesive. It's a bit complex. I'm not going to go through all the cases, but you will see with one or two cases that it's very, very easy to follow and helps a lot in the proper selection of the adhesive. For example, let's start here. Is it a high load bearing application? No. Is large flexibility necessary? Yes. Typically you would select a silicone adhesive. Let's go another way. Is it a high load bearing application? Yes. Is temperature an issue? Yes. Will it operate above 200? Yes. Well, you don't have a lot of choice here. It's either the aromatic adhesive or the phenolic adhesives, those adhesives that are used at very, very high temperature. And see, you can do this, you can follow all these paths, and this will help you to select which are the adhesives for a particular situation. I have also here a case study at automotive industry. Automotive industry is at the moment one of the main sectors, the most dynamic sector in the development of adhesive. They are increasingly used adhesive because they are using light materials to make electric vehicles, like aluminum, like composite materials, and these materials are joined with adhesive. So what are the requirements? There is a big list, of course. You need strength, you need the temperature, you need to be crash resistant, that's maybe the most important, the environmental conditions, the life, typically 15 years, the cure, the wash-off, strength during the production, and be fatigue resistant. We have here in this chart a summary of the previous points in terms of strength, toughness, solvent resistant, hardening time, stiffness, and we have representing this chart how do several types of adhesives behave. And the best one is this one, a hybrid adhesive, this green part, which is typically a crash resistant adhesive. It's very strong, as a stiff epoxy, but it has a very, very high elongation, which makes it very suitable for crash situations. I have here a component. This is a component of a real part. It's the front header of a car and made of aluminum, and we have bonded with adhesive. Can you see? Adhesive here, and then there is a mark here. We impacted it, okay? And we tested several types of adhesives, and in particular a crash-resistant adhesive. And with the crash-resistant adhesive, the capacity of the structure to absorb energy is much higher. Bear in mind that what really is absorbing energy, it's the plastic deformation of the aluminum, but the adhesive needs to hold the aluminum together so that the aluminum can absorb the energy. All right, so that's a typical example of adhesive selection, in this case for a real application, the automotive industry. So that's for the selection. Now let's move on to the adhesive characterization.